rationalizing something with things that aren't square roots is a little bit more involved, and in fact, if you really want to understand it, you have to know more about this thing called the binomial theorem, which we don't really cover in high school anymore. So I'll just tell you what to use. If you want to get rid of these radicals, we're going to end up using this expression. I don't really want to get into why that works out, but I want to show you how to use it. So top and bottom multiplied by this expression that I'll give you for free. It is a smart, good idea to take these radicals and rewrite them as exponents. So just a quick refresher, cube root of x can be rewritten as x to the 1/3 power, and cube root of y squared I can rewrite as y to the 2/3 power. So step one, x to the 1/3 minus y to the 2/3 all over x cubed. I'm going to multiply both top and bottom by the expression I have over here, x to the 2/3 plus x to the 1/3 y to the 2/3 plus y to the 4/3. And now, as I copy this down, I'll just kind of talk while I write. The thing to keep in mind is, we're going to do kind of like a foiling. I'll multiply this x to the 1/3 by each piece of this. I'll multiply this negative y to the 2/3 by each piece of this. And I'll keep in mind that as I do that, when you multiply things together that have the same base, you add the exponents. And what should happen, if I'm rationalizing, is all fractional exponents in the numerator should disappear. If I have fractional exponents in the denominator, that's okay. But in the numerator, they better all go away. So I'm going to think about taking this x to the 1/3 times each part of this. And anytime the bases match, I'm adding exponents. So x to the 1/3 multiplied by x to the 2/3 becomes x to the whatever 1/3 plus 2/3 is. So 1/3 plus 2/3, hopefully we all know, equals 3/3, or just 1. So this guy times this guy is going to be x to the first power. X to the 1/3 times this. This part of it has the same base. So if this is, I'll say, it becomes x to the 2/3, y to the 2/3. And if you're kind of like having a hard time getting your mind around that, it's kind of like if I took a squared and multiplied it by something that was like a cubed b to the 4th. If you have no problem understanding that this would become a to the 5th, b to the 4th, this is the same idea. The part of it that is the same, I'll add those exponents together, and then of course this just kind of comes along for the ride. And then x to the 1/3 times this third piece. There are no common bases, so all I can do is write those two terms next to each other. X to the 1/3, y to the 4/3. We'll move on to the second part of this binomial, negative y to the 2/3. Again, anytime the bases match, I'll add those exponents together. So y to the 2/3 times this first term, nothing in common, so we get a negative. I'm going to always write my variables in alphabetical order. It's a good habit to get into when you start dealing with more complicated expressions. So even though I'm doing y to the 2/3 times x to the 2/3, I'm going to write them down in alphabetical order. X does come before y, right? Yes, it does. All right, so now negative y to the 2/3 times this guy. There's a part where there's a common base. So I'll add 2/3 to 2/3, which is 4/3. Of course, it's negative, so I have negative x to the 1/3. Y to the 4/3, and then negative y to the 2/3 times this guy. I'll add those powers. 2/3 plus 4/3 is 6/3. I'll write this out. I'll have to do 2/3 plus 4/3. That makes 6/3, and that reduces down to 2. So I have a negative y squared. And all of that craziness is going to be over x cubed multiplied by, I'm just copying this down, x to the 2/3, x to the 1/3, y to the 2/3, plus y to the 4/3. Now, hopefully, a lot of things cancel. Let's get a different color. Hopefully, you have someone who cancels with you. Yes, you and you fight. No one wins that fight. You cancel each other out. This guy and this guy cancel each other out. I've done it. I've rationalized the numerator. My final answer is x minus y squared all over this thing, which I don't want to write down again to spare you having me say all those x 2/3 and stuff again. But that's how it works. Take a deep breath, do it. Again, when you do it in your homework, it won't look as complicated as this one. I try to do a harder one in the notes. And It's going to be in the context of finding a derivative, so it'll be a limit of like x plus h minus f of x, whatever. And all your h's won't cancel, but you should end up with an expression where when you plug in 0 for h, you get an answer that's not 0 over 0, and that's the answer that should be your derivative. So good luck with this. Fight through it. I do want you guys to really practice this algebra and know it well. There's a reason why I'm having you do it. I want you to be comfortable with it. And the only way to be comfy with it is to practice it and do it. Let me know if you have questions, please. It's my job to help you, and I want to do that. So good luck.